Hi everyone and good day. So let's continue the next subtopic 2.3 Inequalities. Inequalities play an important role in mathematics just like the equations. There are four basic symbols used for inequalities such as greater than, less than, greater than or equal, less than or equal. So these are the symbols. Inequalities have 5 rules altogether, so let's go one by one. So the first rule is when we adding or subtracting the same number on both sides will preserve the orientation of the inequalities. Adding or subtracting the same number will preserve the orientation of the inequalities. For example, 2 is less than 5, but then when we add number 4, we add the value 4 on both sides of the inequality, the sign less than is remain as less than. When we multiply or dividing the same positive number on both sides, so again it will preserve the orientation of the inequalities. We have 2 less than 5 and we multiply with number 4 on both sides, so the sign less than will remain as less than. However, when we multiply or dividing with a negative number, so it will reverse the orientation of the inequalities. Let's say 2 is less than 5, but then when we multiply with number minus 4 on both sides, the sign of less than will be changed into a more than sign. So we get 2 times minus 4 is minus 8. Minus 8 more than minus 20. So this one is correct. What if we didn't change the sign? So we are going to get minus 8 less than minus 20, which is a false statement because minus 8 is always greater than minus 20. Rule number 4. If a and b is a positive number, then taking the reciprocal will reverse the orientation of the inequalities. For example, a is less than b, but when we take the reciprocal 1 over a, 1 over b, the sign less than will be changed into a more than. And the last rule is, if both sides of inequality are positive and we raise each side to the same positive power, the resulting has the same sense as the original. That means when we have 2 less than 5 and then we give the power 2 to the number 2 and we give the power 2 to the number 5, the sign is still less than. Alright. So linear inequalities. So previously in chapter 2.1, we have learned about linear equations. Alright. So what happened is the linear equation is having the equal sign. But now when we change the equal sign to a inequality symbol, let's say it is less than, more than, less than or equal, more than and equal. So all of this is called linear inequalities. Inequalities can be expressed as interval notation or graph as well. For example, x more than a, so this is the graph representation and this is the interval notation. So all of this you have learned in chapter 1. The empty circle meaning it's not including. Full circle means it is including. Alright, let's do the example on linear inequalities. Solve the following and write the solution in interval notation and graph form. For example, we have 5 minus 3x less than equal to 3. First of all, we subtract minus 5 for both sides of the inequalities. So we have minus 3x less than equal 3 minus 5. The sign doesn't change. So then we have minus 3x less than equal to minus 2. And then to solve for this, we need to divide everything with minus 3. So we have x more and equal to 2 over 3 because we are dividing with the minus value and the sign of the inequalities need to reverse. So x is more and equal to 2 over 3 satisfy the equation. So in interval form, it is 2 over 3 including until infinity, or in graph form, it is drawn from left to right. So this is 2 over 3. Alright, so B, 6x minus 5 is less than x plus 20. So we do the same thing, solve the equation. So finally we have x less than 5. In this case, we are dividing the whole equation with positive 5. So the sign of the inequality doesn't change. So x is less than 5. So in interval form, we have the minus infinity until 5, but not including the number 5. In graph form, it is drawn from right to left. Empty circle. So this is 5. Okay. Alright, how about quadratic inequalities? So that means we have a quadratic equation, but the equal symbol is changed to any inequality symbol. Okay, so there are several methods we can use to solve this kind of inequalities. We have graphical method, we have number line, or we have the constructing table. So we go to the first one, graphical method. So actually we are illustrating the equation by using a graph, and then we identify the region that satisfies the inequalities. For example, we have x squared minus 4x more than 0. So we're factoring the equation x times with x minus 4 more than 0. And then we replace with equal sign for a simpler representation. And we get x equal to 4, x equal to 0 as the solution of this equation. So x equal to 4 and x equal to 0 is the critical point. So how to draw the graph? So 0 and 4 is the root of the equation. So we know that we are having a positive x squared equation. So we are going to draw a smile graph. So just draw a smile graph joining these two values. So we're going to get like this. Okay, so what are the solution of the inequalities? So we are finding the value that gives us a positive number because it is more than. So a positive number meaning, so all of the value on top of the x-axis will give us a positive number, isn't it? This one is the negative number. So the solution is this part and this part. So how to write that? So x is from minus infinity until 0 and 4 until a positive infinity because this one is not including 0. So we have just an open bracket. Alright, the next example, 2x squared minus 3x minus 2 less than 0. We do the same thing. We change the inequality symbol with equal sign for a simpler representation to find the root of equation. So finally, by using factorization method, so we have minus half and 2. So these are the roots of the equation. So note down on your axis minus half and 2, and then just draw a smile graph because we are having a positive x squared. So what are the solutions? So we are finding those with negative answers. So negative answers is below the x-axis. So these are the negative value. This one positive, this one positive because above the x-axis. So our answer is any value of x between minus half until 2, but not including these two values. Okay, because these two values will give the equation 0, but we don't want the value 0. We just want all value that is negative. Okay, so that is the first method. So second method is drawing the number line. So actually we are drawing an arrow according to the sign. So if the sign is more than or greater than, then the arrow should be drawn to the right and the positive sign will be put on top of the arrow. However, if the sign is less than, the arrow should be drawn to the left and negative sign will put on top of the arrow. So we have one important remark over here. So it is important to note that the value of x squared must be positive. So let's say you have a negative x squared equation. You need to multiply the whole equation with minus 1 to have the positive x squared. Alright, for example, this one, x squared minus x minus 12 more than 0. We're going to solve this one by drawing a number line. So first of all, we factor the equation to get the value of the root of the equation. So we have x more than 4, x more than minus 3. Next, we draw a number line with 2 points, which is minus 3 and 4. So let's do this one. X is not including 4 and the arrow is more than. Same goes to this one. X not including minus 3 and the arrow is more than. So since it is more than, so the value on top of the arrow is positive. All positive. Same goes to this one, positive. And elsewhere is negative. Alright, so next step, we multiply these two values. Negative, negative will give us a positive value. A positive value and negative value will give us a negative. Positive, positive is positive. So what do we want? We want a positive answer. Positive answer, so that means we want this interval and this interval. So our answer will be minus infinity until 3 and 4 until positive infinity, but not including the value of minus 3 and 4 because we don't want the value 0. Okay, we just want all value that is positive. Alright, so let's revisit the previous example. 2x squared minus 3x minus 2. So we have done this example previously by using graphical method. So let's try the same example using a number line method. Okay. Alright, so we factor the equation. So we have 2x plus 1, x minus 2 less than 0. Then we have these two cases where 2x plus 1 less than 0, x minus 2 less than 0. So solve for these two linear inequalities. So we have x less than minus half, x less than 2. Alright, so the value are minus half and 2 as the critical point. So next we draw the number line where we have the minus half and the value of positive 2 as the critical point. So let's do this one. X less than minus half, so we have the minus half over here and the sign is less than, so we draw an arrow to the left. X less than 2, so we have the empty sign, empty circle on number 2 and then we have a less than arrow. Okay, and the value on top of the arrow is all negative because it is less than and otherwise they are positive. Okay, otherwise it is positive. And next we multiply those signs. Negative with negative will give us a positive. Negative, positive is negative. Positive, positive is positive. So what do we want? We want a negative value not including 0. So negative value is this interval from minus half to 2 but not including these two values. So how to write down? So this is the way we write down our answers in interval notation. Alright, so we have the same answer as the graphical method. So using any method, so you are going to get the same answer. Alright, the third method is by constructing a table. So first of all, we need to factor the quadratic equation to find the critical points and identify the interval. So based on the interval, we create a table and then we choose a test point that represent the interval to identify the results of that interval, whether the answer is positive or negative. Let's try this example. We solve the x squared plus 4x minus 5 less than equal to 0 by using constructing table. So first of all, we find the points, the roots of the equation, which is minus 5 and 1. Alright, so that's mean in our number line, we have minus 5 and then we have 1. So from this number line, we can create three intervals. The first one is less than minus 5. Second one between minus 5 and 1, and lastly which is more than 1. So transform the interval into a table like this. So since we are solving less and equal, so for this one, so we have x less and equal to minus 5. So this one, x between minus 5 and 1, so we have the equal symbol as well. And for x more than 1, we also have the equal symbol. So for the test point, we pick any values that satisfies the interval. For example, for this interval, we are using minus 6. For this interval, we take 0 as the representation, and for this one, number 2. So for each of the values, we plug in into these two brackets, into these two factors, and just write down the sign of this solution. For example, minus 6 into this equation, minus 6 plus 5, we have minus 1. So the answer will be negative for all values that is less than minus 5. For the values between minus 5 and 1, for example, 0, plug in into this one, so we have positive, and repeat the same thing for the rest of the interval. And lastly, we multiply those signs. For this case, minus minus, so we have positive, plus minus, we have negative, plus plus, we have plus. So what are we finding? We are finding less and equal value, which is negative value. So our answer is this interval, minus 5 until 1. Alright, so this is the answer. Alright, the next part is rational inequalities. So previously we have linear inequalities, we have quadratic inequalities. So right now we have a rational inequalities. So a rational inequalities involve the rational expressions P over Q. So we have some expression dividing by another expression. So how to solve a rational inequalities? So first of all, we write the inequality so that one side is 0 and the other side have only one fraction. So we need to simplify until we get into this form. Second one, we find the critical values. The third one, we draw a number line or a table to indicate the critical values. And lastly, we choose the interval that have the sign which satisfy the inequalities. So let's check out the next example. For example, we have x plus 1, 3 minus x more than 2 using the number line. We would like to find the value of x. Alright, so first of all, we need to simplify this equation so that we have one fraction on one side and another side is 0. Alright, so after getting this, so we break into two cases. So 3x minus 5 more than 0. And then 3 minus x more than 0. So this is the second one. So for those two cases, we identify the inequalities for x. So we get x more than 5 over 3. X is less than 3. So create a number line like this. So 5 over 3 and 3 are the critical points. So for this case, x more than 5 over 3. So an empty circle and then a more than arrow. So the value on top of the arrow, we need to identify by choosing the values that satisfy the below interval. Alright, so next we choose one value between 5/3 and 3. Let's say 2. So the number 2 into this expression. So 3 times 2 is 6. 6 minus 5 is 1. So we have a positive. So same goes to this one. Let's say number 4. So 4 into this equation, we get a positive value. For this one, let's say 0, something that is less than 5/3. So 0 into here, we have negative value. So repeat for the second expression, 3 minus x. We have x less than 3, so empty circle, and less than arrow. So this one positive and this one negative. And lastly, we multiply those signs. So negative, positive, negative, positive, 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 negative, and negative. So what do we want? We want a positive value. So positive value is those in the middle. So how to write the answer? The answer is x between 5/3 and 3. Alright, so without including the numbers, or we can write in an open bracket as well. Alright, the last example. So we have x squared plus x plus 6. Now our x squared function is negative, and divide by x plus 6 more n equal to 0. So now we would like to use table, test point method, which is constructing a table. So first of all, we need to have the x squared function in terms of a positive value. So how to do it? So we multiply with -1. So we have x squared minus x minus 6 less than x plus 6. This one doesn't change because we multiply negative for on top of the fraction only. And the sign will reverse, okay, from more than into less than, because we multiply with a negative value. So this is inequalities rule. And then we factorize the numerator. So we have x minus 3, x plus 2 over x plus 6. So now we have three cases. So x plus 6, for this one, x plus 6 lies under the fraction, which is the denominator. So the denominator of a fraction cannot be 0. So there is one condition over here. X plus 6 cannot be equal to 0. And x can be any number except -6. So this is one of the condition. And next one, for the first bracket, x minus 3 equal to 0. We have x equal to 3, x plus 2 equal to 0. For the second bracket, we have x equal to -2. So these three values, -6, +3, and -2, are the critical numbers. So on our number line, we have, let's arrange all the numbers. We have -6, we have -2, and then we have 3. So there are 4 intervals. So there will be 4 columns inside our table. First column, second column, third column, fourth column. Represent all 4 intervals. So we have x less than -6, x between -6 and -2. Alright, so remember, the sign of the inequalities, we have the equal sign. For this one, we cannot write x less and equal because x cannot be -6. So we need to omit the equal sign for the first interval. Okay, for here. So we have x less than -6. For the second interval between -6 and -2, again, we cannot have the equal sign for the -6. And this one, we can have the equal sign. It doesn't matter. The expression will be valid. And the last one, x -2, 3, and x more and equal to 3. So these are the 4 intervals. So choose any point that belongs to those intervals. For example, -5, -1, 0, 4. So for all of the values we plug in into the three brackets that we have in our previous expression, inequalities. Okay, into the three brackets. So we have x minus 3, x plus 2, and x plus 6. So we have x minus 3, x plus 2, x plus 6, and sub the value and identify the sign. So in this case, we have negative, 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 positive, and so on. Alright, and lastly, we multiply all those three signs. Negative times negative, positive. Positive times negative, negative. Negative, negative will be positive. Positive, positive will be positive. Negative, positive, negative. Negative, positive, negative. And positive, positive, positive. Alright, so what are we finding? Are we finding a negative answers or a positive answers? So let's go back to the question. So we have positive over here, but because we have already multiplied the equation with minus 1, so our equation now is less and equal. So we are referring to this. Alright, so we are referring to this, not the original question. By right, it is the same, but the table reflects this expression. So we need to refer to this expression, which is less and equal. So we are finding negative answers. So the negative answers is this one and this one, resulting this interval and this interval. So the answer is x less than minus 6 and x between minus 2 until 3. Alright, so these are the solutions. Alright, so with that, we already end our 2.3 subtopic. So see you in the next video, 2.4 absolute value. Thank you.